8.2 is the distribution of sample proportions. So it says, in an election, how convenient, the election was yesterday, right? In an election, polling companies wish to estimate the percent of people who will vote for each candidate. This is clearly a situation for sampling, as it's impractical to contact every single vote. So people want to try to get an idea of who's going to win the election. So they call you and say, who are you planning on to vote? Who are you planning on to vote? And they get an idea before the election actually takes place of who has what percent, all right? So the desired results are called proportions, guys. The desired results are called proportions. It's what proportion out of 100 plans on voting for candidate A. So for example, 59% is going to vote for candidate A. You're like, yes, we should win the election because we have a majority of the vote, blah, 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 okay? So what's going to happen is we're going to be able to come up with a mean for sample proportions. We're going to be able to come up with a standard deviation for sample proportions, and thus we're going to have a distribution, and we can do everything we did in 8.1 and 7.2 where we can standardize it, change it to a z-score, use our gray sheet, and figure out probability, okay? So we're going to take a random sample of size n. Each individual either has the characteristic or not. So you're either voting or not voting for candidate A. You're either 6 foot or not 6 foot, or whatever it may be, okay? So in total, there are always X individuals that have that characteristic, right? So our sample proportion, guys, is what we're finding. And like I said, this is something totally new. We have not talked about this. This is a new variable for you, sample proportion. And what is he? He likes to party, so he has a hat, party hat on, okay? That's P hat. So P, solid P, is your population proportion. P hat is your sample proportion, okay? Where he is found by taking X over N. What is N always to us? The sample size. And what is X, guys? X was just told to you right up there, so we'll just do an arrow. X is the number of individuals that have that characteristic that you're asking about, okay? How many are voting for candidate A? How many are taking another math class, whatever it may be, okay? How many have blue as their favorite color, all right? And you'd be able to come up with a proportion. All right, so let's just first make sure we know how to figure out what P hat is. So let's look at this example. It says, if a polling company polled 800 people to see if they supported a certain issue, and 475 said yes, they did, then we have a sample proportion problem with, well, what is our N in this case? How many total people did we ask? 800, right? We asked a total of 800 people. Of those 800 people, though, how many said, yes, I support the issue? 475. Thus, we can find our sample proportion of P hat because he's always X over N. How many total people said they supported the issue? 475 of the 800. Throw that in your calculator, round to 2 decimals, and you get 0.59 or 59%. It is probably important to note in 8.2, guys, we're going to keep proportions as decimal form, okay? So if they give it to you as a percent, make sure you change it to that decimal form of 0.59. All right, so kind of keep this in mind because sometimes you'll have to calculate P hat, but sometimes they just might say, hey guys, I asked 800 people and 59% of them supported the issue. P hat was just handed to you on a platter. You didn't have to calculate it, okay? So be careful there because sometimes we always think we have to divide by N. You don't. If you're given a sample proportion in percentage form, he's already found for you. All right, so what do we want to take away from this? Well, we are going to be able to come up with a distribution, but there's some key things we have to remember. So we're going to kind of star this area because this is important to help us with our problems. First of all, we have to make sure that our sample size N is less than or equal to 5% of our population size, okay? Our sample size N is less than or equal to 5% of our population size. This rule makes sure that we have randomly selected individuals without replacement, all that kind of stuff. This rule, if we have to make sure that N times P times 1 minus P is greater than or equal to 10. That rule makes sure that we have a normal distribution, okay? It's some random calculation. Remember on Monday how we said if n's greater than 30, we're good to go? Well, for proportions, if this is greater than or equal to 10, we're good to go. It's just kind of a stipulation to make sure we have a normal curve. So this proves normality, proves normal. Just so you know, okay? So, if these two conditions are met, guess what you have? Your mean for your sample proportion is just P, your population proportion. That's just your population proportion. AKA what you would expect, right? Our means don't change, our proportion doesn't change. If you expect 59% of people to be voting for a candidate, then that should be the average. Our standard deviation, guys, this is the formula for standard deviation. We're going to have to calculate it, okay? But he's not too bad because we'll be told P. So we'll have P times 1 minus P all over N, our sample size. We're told all of those. And then we'll take the square root, and that will give us our sigma. So guess what we can do? We can take our random variable, P hat, subtract the mean, mu, and divide by sigma, and guess what we have? A z-score. Bless you. So let's go ahead and look at the top of page 7. This, again, is important, so if you haven't been listening to me, listen to me now, because if we leave this blank, you're screwed, okay? What we're going to do is we have the z-score formula. Z is just going to be our sample proportion minus our mean of p hat divided by our sigma of p hat. Okay? So instead of x minus mu over sigma, or instead of x bar minus mu of x bar over sigma of x bar, we just have p hat minus mu of p hat over sigma of p hat. So it's always your mean and standard deviation. This little guy changes. What do I also say? Well, if you don't want to do it individually, you can actually do it all at once. Okay? So p hat is p hat, but what is mu? We just stated it on the bottom of page 6. Your mean is just the population proportion they give you. All over sigma, but what's the formula for sigma? P times 1 minus P over N, okay? So these are equivalent. You can use one or the other. You don't have to use both, okay? So MyMathLab usually pushes you this direction, where they say, okay, find mu first, fill that in. Find sigma second, fill that in, and then you can just go right to this formula. But on the test, guys, I'm just going to have a blank. Actually, I don't know. I might follow this where you can fill it in. So I might ask for those. If not, you can just do straight from here. What was mu? It was just the population proportion they gave us. What was sigma? Well, we had to calculate it using this formula, okay? So you can use one or the other, guys. You don't have to use both, all right? So let's see what's going on here. It says, according to the National Center for Health Statistics, 15% of all Americans have hearing trouble. If 120 Americans are randomly selected, what's the probability that at most 12% have hearing trouble? So let's look at this. Let's go back and label things. In all the problems before this, they always said the average is, or the mean is, right? They always told us mu. So this is P. But guess what P is? It's mu, right? They always tell you the population in general. Like, we expect 15% of all Americans to have hearing trouble. So if I ask you guys, I would expect, I don't know, what's 15% of 20? Whatever 15% of 20 is, I'd expect that many of you guys to have hearing trouble, all right? And then if we ask 120 Americans, what's 120? N. That's how many people we ask. What is the probability that at most 12% have hearing trouble? Who's that? Well, we're asking 120, so we're taking a sample, and this is a percent that goes with the sample. That's our new guy. That's p hat. That's our sample proportion. So this was what I was talking about. We didn't actually have to calculate them, x over n. It didn't say if we asked 120 people and 35 of them have hearing trouble, right? It gave us the percent. We know it's 12%, okay? Keep in mind what at most means, because that's going to tell us which direction we're shading, so we know what to do once we use our z-chart. All right. So step number 1 is those two inequalities that we must prove. We must prove that little n is less than or equal to 5% of big N. And we must prove that little n times p times 1 minus p is greater or equal to 10. So to determine if the distribution is approximately normal, these two inequalities have to be true. All right? If they weren't, you say, whoop, can't do the problem, see ya, and you would be done. All right? So all of your problems on MyMathLab, they are. So guess what? You can always click. Yes, they are, right? On the test, though, I'll ask you, step 1, prove that they're true. You'll grab these inequalities from the formula sheet and fill them in, okay? So the question is our sample size of 120 really less than 5% of our population size? But do we know our population size? No. But who did we ask? Americans. Do you guys agree that 120 is easily less than 5% of all Americans? Yes. That's going to happen a lot, okay? You're going to do a lot of hypothetical answering on that question because they rarely tell you the population. So we'll say yes, 120 is less than or equal to 5% of all Americans. I don't know what the population of America is. Are we in the trillions? Billions? Okay, isn't that horrible that I have no clue? What is it, 324 million?
Yes.
That makes sense, because the big cities are like 1 or 2 million, right? And then all the other combined. Isn't that awful? I have no clue. So 5% of 324 million is easily bigger than that 120 that we took. So we're good there. Then over here, we have to make sure N, 120, times P, so that's normal P, 15%, times 1 minus P, or 1 minus 0.15, is greater than or equal to 10, question mark. And that's one that you can just throw in your calculator exactly like that. So will somebody do that real quick? Well, they take 120 times 0.15 times 0.85, or 1 minus 0.15, it doesn't matter, and make sure that we get a number bigger than 10. Yeah. What do you get? 15.3 is greater or equal to 10, check mark. Okay, so this is how your test is going to be. So I don't want to say your next 2 weeks are going to be kind of easy, but they are, because Monday there's no class, and Wednesday we're going to, I'll try to get the computer lab, and so we can go to the computer lab and review and so forth. And then the following Monday will be the test for chapter 6, 7, and 8. But then that Wednesday you don't have class because you have Thanksgiving, okay? So 2 weeks you don't have to listen to me lecturing, which is kind of nice. You'll get a break from that. So on the test, though, your very last problem on the test is going to be one of these, the proportion ones, okay? And step number 1, I'll ask you to prove that it's normal. So you're going to pull these inequalities from your worksheet. And actually, I think I just have you prove this one because I don't like that one because we rarely get the population. All right, enough of that. So now let's determine mu of p hat and sigma of p hat. Well, we were just told on the bottom of page 6 that the mean is p. The mean is the population proportion. And what did we say the population proportion was for this problem? 0.15, 15%. I heard it a couple times. Okay? We would expect 15% of people to have hearing issues. What is sigma of p hat? This is the only sigma of p hat. I shouldn't say only, because I guess you kind of have to calculate it in 8.1, but we really have to calculate it. There's no sigma told to us, right? So we're going to use the formula p times 1 minus p all over n, and that's under the square root, okay? So we're going to do the square root of 0.15 times 1 minus 0.15 all over 120. Okay, so depending on which kind of calculator, if you have one of those newer ones where it lets you do everything under the root, go ahead and do everything under the root. If you have one of the older ones, what I do is I do the inside first. So I do 0.15 times 1 minus 0.15 divided by 120, hit enter, and then I do second square root, second answer. So it does all the square root. I don't know if you guys use that second answer button. I really like that. This is one where they're going to be ugly answers, they're going to be decimals. Think of it, it's standard deviation, so it's error for percentages. So it should probably be kind of like single digit percentages. So I mean, it should be 0.0 something a majority of the time, okay? So we're going to run around to like 4 or 5 decimals. If you do this, you get 0.0326. Does that look good for those that did it? 0.0326. So make sure you can get that in your calculator. Do you have to draw the normal curve on the test? No. There's only one problem where I say, draw it, shade it, tell me the area, and that's all. All the other word problems, if you don't draw a single chart, that's fine. But I just kind of want to show you what we're doing, okay? So the normal curve is the everyday real life situation where the mean is in the middle. So what was our mean? 15%. So we expected about 15% of people to have hearing issues. A little more have higher, and a little less have that, okay? So that's always our mean, but where do we care about? We care about p hat at most 12%. So where does 12% go on this normal curve? On which side? The left. And again, we're kind of just eyeballing it. I don't care as long as it's on the correct side, okay? So we'll just do like 0.12 over here. And then we have to decide, guys, which direction are we shading if we want at most 12%? To the left, right? At most is a cap, no more than, right? At most is a cap, so we're going to just shade to the left. And again, celebrate the small things in life. You know what that means? That means when we go to that Z chart, we're just pulling that area. We don't have to do anything from it, all right? So what are we going to do next? We're going to convert our p hat to a z-score because I don't have a chart that has me hearing issues on there, right? So we're going to do z equals p hat minus mu of p hat over sigma of p hat, and we're going to fill in everything we have. P hat was our sample proportion that we either found or were told. In this case, it was 0.12. Minus mu of p hat, which we just answered right above. It was the population proportion, 0.15. Divided by our sigma of p hat, which we answered above and calculated, which was 0.0326. Okay? So you do the difference on top and get a negative 0.03 over 0.0326 and divide the two. Round your z-score to 2 decimals, so that will tell us our chart, where to go. You guys get negative 0.92. Does that look right? Okay. What does that mean? Again, I want to try to make it make sense to you as much as possible. Your z-score is how far you are away from the mean in terms of the standard deviation. So if you go back and you look at our standard deviation, it's a little over 3%. And don't you guys agree that 12% is exactly 3%? Okay, so we're almost a full standard deviation away, right? This difference between 0.12 and 0.15 almost matches that exactly. So that's why it's almost exactly a -1, right? It's not quite a full standard deviation, so that's why it's a little short of a -1. All right, so now we can draw the standard normal curve. Standard normal just means what? What's always in the middle? 0. And now our proportion of 0.12 has been changed into a z-score, a negative 0.92. Again, it's still on the correct side. So since it is on the left side, you just go to negative 0.9, scroll over to the third column to 0.02. What area do you find? 1788. Sounds like a year, doesn't it? 1788. All right, so for purposes of my test, you would be done. You could circle that and you could say, hey, 17.88% of those have a chance of having 12% or less of hearing issues, okay? But just for notation to feel comfortable, what did we do? We found the probability, so that's why we have a big capital P, of the sample proportion, so p hat, being at most, so less than or equal to 0.12, right? We wanted to know the probability that our sample proportion was at most 0.12, so less than or equal to 0.12. But we said we don't have a chart about hearing issues, so what did we have to do to our p hat? We had to change it to a z, and it's changed to negative 0.92. And what was that probability? 0.1788. We have about an 18% chance of asking those 120 Americans, and 12% or less had issues. All right? I know Spencer's one of the ones that answered it yesterday. What if I asked 1,000 samples of size 120? How many of those 1,000 samples would have hearing issues of 12% or less? 179 of them. Right? It's that whole idea of you take your probability that you calculate and multiply by that n so you can get that answer. All right, last problem on chapter 8. It's going to be the exact same situation. If the sample of size 120, so that again is still our n, resulted in 26 having hearing trouble, so that's actually our x, okay? So they're actually giving us a p hat that we have to calculate. I'm going to still mark up here, guys. Our P was 0.15. I don't want to forget about that. 15% was the proportion from page 7. So 15% of Americans are supposed to have hearing trouble. So we want to know if we ask 120 Americans and 26 of them had hearing trouble, would that be unusual? So it's kind of weird because they're not flat out saying what is the probability, but do you remember what unusual meant? Less than 5%. So they are kind of asking probability, right? They want us to find the probability and then compare it to 5%, all right? So less than 5%. Keep that in mind, all right? So if you're okay with it, since I'm using the exact same problem, we proved this on page 6, right? We don't need to do that over again. We proved that our sample size of 120 was easily less than 5% of our population. N times P times 1 minus P was greater than or equal to 10, okay? Mu of P hat, let's write it down just to remind ourselves. Mu of P hat was P, which was 15%. We would expect 15% to have hearing issues. And sigma of P hat, we had to calculate, but we already did that, so let's just write that down, 0.0326. Again, these are from page 6. If you need to be like, where did these magic answers come from? Those are from page 6. We already did that. Yes. Sorry. I'm used to being on 7 and saying 6. Change that to page 7, guys. We're on page 8 now. Thank you, Brittany. All right. So now what we're going to look at is we're going to draw the normal curve. But in order to draw the normal curve, just the normal curve, we have to know what our average is, which is 15%. And we want to plot P hat. But do we have P hat right now? No. But can we find him? Yes. P hat is X over N. In this case, 26 over 120. When you do that, if it's an ugly number, round to as many decimals as possible. So is this one, I think is it 0.216 repeating? So I'm going to put that repeating bar on there. So when I go back and do my calculations, I'm going to put 6666666 so I can be as exact as possible. Because if you round too soon, like if you round that to 22%, it's crazy how big of a difference that makes in your answer, which makes the probability change and which makes you frustrated, even though you did it right. That's what's nice about a pencil and paper test, guys. If you do that and you round to 22%, I will follow through the problem with your 22% and make sure you did it all right. You'll get full credit. On my math lab, they won't want you to round that quickly, okay? So let's go ahead and convert our z. So z equals P hat minus mu of P hat over sigma of P hat. But we already know what our P hat is. We just calculated it up here. It's 0.216 repeating minus mu of P hat, which we stated up there was 0.15. Oh, we didn't shade. Sorry, I'm going to go back to that. And then we have 0.0326, okay? So first of all, let's shade. Where is 0.216 according to 0.15? On the right side, okay? And this is almost like a trick question, but what direction are we going to shade? It's kind of hidden in there, and it's hard for you to see, but it says, if we asked 120 Americans, resulted in 26 having hearing trouble, which direction are we going to go? Left or right? Okay, let's say we shade to the left. What kind of numbers do you have? 26 or less, right? Would that mean 26 had hearing issues? No, less than 26 had hearing issues. If you shade to the right, what would it be? 26 or more have hearing issues, but hey, if 30 people have hearing issues, don't 26 people have hearing issues? It's kind of a trick question. 26 is hidden in any number bigger than 26, right? So this is shaded to the right. So when we go to look up our z-score for the area, we have to remember to either look up the opposite z-score or subtract it from 1. All right, let's go ahead and do the math. In your calculator, when you do this difference, make sure you type a bunch of 6s, okay? So type 0.21, 6, lots of 6s, subtract 0.15, hit enter, divide by 0.0326. You should get 2.04. Tell me if you don't. And I'm going to do it the wrong way. I'm going to tell you what happens if you round too soon. So if you do 0.22 minus 0.15 divided by 0.0326, you get 2.15. That is a huge difference between 2.04 and 2.15 on here as far as area goes. So that just shows you how important it is to be as accurate as possible. All right, last time we had to draw the standard normal curve. We're just going to draw the curve centered at 0, but now instead of graphing our sample proportion of 0.216, we're going to graph 2.04 and shade to the right. So whatever area we shaded, that represents the probability, okay? So how are we going to find the area? I subtracted from 1, but if you look up negative 2.04, guys, you'll get the same answer, right? Remember, you can look up the opposite. But I'm going to look up 1 minus 0.204, which is 0.9793, which gives me an area of 0.0207. And is that what you get if you look up negative 2.04? Yeah. Okay. So, again, for purposes of just making things make sense to you, what the heck did we do? We found the probability of our sample proportion being greater than or equal to 20.216 repeating. Okay? But we said we don't have a chart to tell us about hearing issues. So we had to change our probability and our score to a z-score of greater than or equal to 2.04, which equals 0.0207. But is that what it asks? No, you go back to the original question. It says, if the sample of 120 Americans resulted in 26 having hearing trouble, would that be unusual? Yes. What was our chances? Yeah, right, because it's only 2% chance, right? So yes, unusual. Because really, we had just barely over a 2% chance of having that happen.